Welcome to part 1 of my lam.shop tutorial, where I will teach you how to make lam.shop. Or rather, we'll just be going through the core components of what makes lam.shop good, um, and yeah, how to make it, essentially. Um, so, basically, what are sessions? So, sessions are just meant for the storing of data throughout your browsing session, right? So, this usually um, this usually consists of two parties. So that is your client and the server. So the client will hold an authentication cookie, and then this authentication cookie is used to identify your session, which is basically, yeah, the server uses the authentication cookie to identify which session uh, that is, of all the sessions, they'll use this authentication cookie to identify which one is you. So this authentication cookie usually needs to be cryptographically secure. And so, um, yeah, on the server, the session data is usually stored here. However, this is more the case in uh, backend architectures like PHP or ASP.NET. Now, I did mention that it needs to be cryptographically secure, but how? Although in PHP, which I've dealt with before, it's usually not something you have to worry about. You can just literally call underscore session and it just works, right? It just works because it manages the cryptography for you. But um, for Flask, we'll need a secret underscore key, and this will be used, or rather, the bytes in this secret key will be used to hash the authentication cookie. Now, yeah, so in the case of Flask, all the session data is just stored client side, which is not very secure because the you know the client is able to modify the data if they get a hold of the secret key, which in PHP, for example, you can't just do that, right? So how do we begin using sessions? So one main use of sessions would be for login purposes. So let's say I log into a website like um, lam.shop, right? And I key in my information. How does it remember that I'm logged in every time I visit a page? It uses sessions. Like basically, when I log in, it starts a session, and then it keeps track of, you know, the data throughout this browsing session. So as long as this authentication and cookie exists, my session exists, and so it knows I'm logged in, no matter how many pages I go to, until I press log out, where it will just clear the session. Now, how do we write this for ourselves? Here I have my login and a sign up. As you can see, I won't really go through the HTML because they're quite similar. We just have a basic form. We have a basic form here uh, that posts to their respective action links, which is login and sign up. So yeah, basically, for in order to even begin writing in Flask, working with Flask, we'll have to import Flask. So we'll have to initialize a new instance of Flask, of course, and then if the caller of this script is, us and not another script, then it will run the script. And we can't just run Flask from, another script. However, how do we implement this secret key that I've described here? This secret key usually will have just a random string of characters, right? Um, or rather, we'll have a string of characters that we preset in place. However, in my case, I've decided to just randomize it every time that I run the script because I'm lazy to come up with something. So I just imported OS, and OS generates a random string of bytes. And then I convert that to hex, which is hexadecimal, of course. And this will be a string, essentially. And then this would act as my secret key, which will be used for cryptographic purposes. Now, now that this secret key is initialized, or rather it's defined, we can now make use of sessions. So, for my login page, we have so app.route is a decorator. So basically it tags itself to this function. It calls this function every time I go to this page. So I've specified there are two methods, get and post. This, get and post. So for this page, I also don't want them to, if a user is already logged in, I don't want them to access this page because why would they need to log in again, right? So if they're using a get request, basically they're asking for the HTML, CSS, and JavaScript files of this page. We'll check if their session already exists. So if their session exists, we'll have some data inside it, and so if there's a username stored in their session, and the session is not just blank, right? That means they're logged in. So we redirect them to index, which is just this page here, because we don't want them to be able to access login. If I were to try to access this, it'll just redirect me. Otherwise, if they're not logged in, we'll just let them access it anyway, right? Now, since I've only declared that there are two possible methods, if it's not a get, it's got to be a post. So we connect to lam.shop.db, which is our database, and we also have to make use of SQL because in order to keep track of all the usernames and passwords, we'll need to have a database in place so that we can access all this data. Now, this means we'll have to import SQLite 3, and then we'll have to create a new connection. So this will be SQLite 3 dot connect, and then we'll have the name of our database. Now, one thing about SQLite 3 is that it's serverless. So basically, as long as I have a database file, it will just read and write to that database file. I don't have to have a server up in place. So for this login, we'll have to connect to the database, and we'll need to have a cursor. So we'll have a cursor. Now, what is a cursor? A cursor is basically this little flashing rectangle that tells me where I'm at in the where I'm typing, right? So in order to log in, first, of course, we have to get the password and the username. So this is the input user, which is basically what the user input for their username. And this is their input password. This is the password that they input. And we'll encode this in UTF-8 because we need to get this in bytes. So how logins work for in order to make it secure, usually we'll have okay, let's say this is users, right? This is a table called users, right? Or rather accounts, right? We'll have maybe an ID, and then username, uname, and a password, right? Now, it would be not very smart to store the passwords in plain text, right? Because if anyone breaks into, they breach security and they manage to get a hold of the database, they'll be able to just view everyone's password in plain text. So yeah, that's not a good thing. So usually we'll have the passwords are stored as hashes. So this will be already hashed, right? It's already hashed. And you might be thinking, wow, if it's already hashed, how are we going to be able to check that our password matches this password? Because we don't even know what the password is from the hash. Well, using a bit of common sense, we'll just hash the input password and see if the hash matches what's inside here, right? Now, so for example, if I have a hash password of like ABC123, right? This is already this is the hash. Usually it will not look like this, but okay. And I input a password that's like lam goat, right? And I hash this and this is BBC123. This doesn't match the hash that's inside the database, and so yeah, doesn't work. So here we'll basically be executing a query from SQL, in SQL within this database. So we'll be accessing this table users, and we'll be selecting a password where the username is this. So we put a question mark here so as a placeholder because in Python for SQLite it's already whatever we put into here as a second parameter will a second argument in this tuple will be automatically escaped. So in PHP we'll have to do like we have to have MySQL, MySQL. This is MySQL, not SQLite 3. So then we'll have a connection, and then we'll have to be like MySQL QL escape string, right? String, and then we'll have to pass in what we want to escape. However, in Python, this is already built in. So yeah, it just assumes whatever you put into this tuple is dangerous input, and they just sanitize it for us. And so we'll also fetch one row. So for example, within this database, if this query returns us more than one row, it'll only fetch the top row. Now, that's the only thing we need to do, because after that we can just close the connection. So if this returns nothing, it'll just give a message, right? It'll give a message. So let's log out here and test it out. And I say this password is just a bunch of gibberish, which will not match anything, right? It'll just return this same page with a message, incorrect password or username. And you can see here, there's a p tag with a placeholder here, So if there is any message, it'll show it here. Usually, if I were to access this page, right? If I were to access this page without, typing in anything, like for the first time, there's no message, so it'll just be blank. Now, so after we close the connection, we just check that, if there's a username match, So it'll search here, it'll select the password from users where the username is equal to, the username that they input. So if nothing comes up, that means there's no account, there's no user in the database where the username is whatever this is. That means the account doesn't exist, basically. But otherwise, if this query returns a row, we'll check that the input password matches the queried password, right? Because will return this will return a tuple, right? This will return a tuple. For example, since there's only one row, this tuple will basically just be the hashed password. So we can just go in the first element, which is just the hash password, and encode it, because this whatever we put into the database is going to be in it's going to be text, so we have to encode it into bytes. See, take note that here we already encoded it into bytes. So in order for bcrypt, which is the cryptographic algorithm that I'm using to check the passwords and match them, we need them to both be in bytes. So this function, checkPW, basically hashes the password for us. So here is the input password, right? And this is already in bytes. It'll hash it and then match the hash to the second argument. So yeah, as you can see here, password bytes, hash password bytes, both of them have to be bytes, and this will return a boolean true or false. And if this returns true, this will uh, generate, yeah, this will store in our session that our username is this input user, and session.permanent is true. So session.permanent in Flask, if we set it to true, it's not actually permanent, it just sets it to 30 days. So this auth cookie, the session cookie, just sticks around for 30 days. And then um, after the 30 days, it'll just make me log in again. And then once my session is initialized and everything, it'll just redirect me to index, which is the store page. Yeah, send me to the store page. Yep. And yeah,